Greetings and welcome. In this video session, we will discuss about types of flow lines or flow pattern.
So have a nice day. Today in this session we are going to see types of flow lines. Okay, 8 classifications in last session we have seen. In that, steady versus unsteady, laminar flow, turbulent flow. Okay, one dimensional, two dimensional, three dimensional, compressible, incompressible. Okay, so in that way different classifications we have seen. Now these classifications we have to group together, means whenever the flow is taking place, okay, in various examples in a fluid mechanics, then that flow is represented by using some lines. Okay, that lines are called as flow lines. So here prominently 3 types of lines are used in a fluid mechanics to represent flow. Okay, so these lines we will see in this session. So these lines are, one is a path line, okay, path line, second is a stream line, and third is a streak line. So what exactly difference among these 3 lines that we are going to see? We can say it is a pictorial representation. Pictorial representation means view, how it looks. Okay, now to show this line there are some techniques which are used, that also we will discuss here, and practically also I will show that in a lab. Okay, there is one practical, we will see that. Today is in a middle session, we have practical, in that we will see also there. Okay, so the first line is what? Path line. So about the flow lines in a brief, just have note that is what it is, a geometry. Flow line is what? It is a geometry of fluid motion. Geometry means what? It has some dimension. Geometry, it has some view, pictorial view. Okay, and it happens or it comes when the fluid, when a fluid is in motion. Definitely when the fluid is in stationary, means a fluid in a tank, fluid in a reservoir, that is not in motion. So in that case we will not have such kind of picture. We can't say that it is a flow. When the fluid is flowing, then we say it is a fluid, and in that fluid flows in different way. Okay, so when a fluid is in motion, it's innumerable. Innumerable means number of, infinite number of particles. Fluid is consisting million number, n number of particles. So that is why it's innumerable particles move along a certain direction. Certain direction or certain path or line. When the fluid is flowing, it takes some path, that is a certain path or line or direction. In a different way we can understand, and again it happens depending upon case to case, it is a different, depending upon condition of the flow. Condition means what? Velocity. If the velocity is a low velocity, then we get a laminar flow. When the velocity is higher, we get turbulent flow, in that way. Okay, condition of flow. Again, condition means what? If the flow is through pipe, we have internal flow. when the flow is in a channel, external flow, that condition. So this is the first point, this is a second point, and third point is what? Types of flow line is what? Visualization. Visualization means to show, for the better understanding, picture form, visualization. So visualization. Visualization of flow is done using different lines. These are flow lines. Okay, these are what? First is a path line. Second is a streamline, and third one is a streak line. So these three lines. Okay. First line, path line, has some meaning with its own title, but streamline and streak line, it has somewhat technical aspect. Okay, that we will see one by one. So first, path line, how it looks, path line. So for that we will have one picture. These are the lines, suppose. As the flow is taking place, okay, the fluid particle, suppose, has started at t is equal to 0 time, and it is following some path. So it will follow path at first t is equal to time is equal to 1 second at this point. In this way, different points are followed. This is a time. So this representation, such kind of representation is called as path line. It has no any definite order while showing such kind of flow. It has no any kind of order, we see. Means either these lines are parallel, either nor these lines are crossing. Okay, path line. So it is a path followed by, it is a path followed by a fluid particle in motion. And in fluid kinematics first lecture, flow description, in that we have taken two methods, two approaches, Lagrangian approach and Eulerian approach. Lagrangian approach is based on particle approach. So this is what particle approach, because here the flow is represented on the basis of particle motion, location of the particle. So that is why this is particle or Lagrangian study or approach. It shows direction of particular particle. It shows direction of particular particle. Okay, so this was about the path line. Second type of line is streamline. In the word title we see stream. Stream means a particular region, stream of water, current of water which is flowing, stream. So it is imaginary line actually. Okay, how it will be shown? See, suppose these are the lines. Suppose these are the lines. Then the line which are drawn, okay, these lines will have some points. These are some points. So it is an imaginary line within a flow, so that tangent, see, this is a line which is curved in nature. At this point, if I will draw tangent, then it will go in this way, tangent. So it will give us direction of that velocity. It shows the direction of velocity, tangent drawn at the point. So similarly here, these are the directions of velocity at this point. Okay, similarly if it is changing this way path, then at the next location here, now here we will have mathematics. First of all, write the definition. It is imaginary line. Imaginary line means what? This is actual representation, but these are velocity vectors, these are imagination that we don't look or that we can't visualize. Velocity vector in the flow pattern we can't visualize. We have to consider by using mathematics. Okay, means by taking instant of timer at a t is equal to 0 seconds. Suppose this is a particle. To represent that we use different ways. So it is an imaginary line within the flow. Within the flow, so that tangent drawn at any point on it means on line, on it indicates means shows, indicates the velocity, indicates the velocity of that point, Now for the better understanding or clear the, here we will have again Cartesian coordination system. X and Y, XY plane we will take. In the XY plane we will take one of the line. This is a line, flow line. On this line, this is a suppose point. Okay, at this point we will draw the tangent. Okay, now this tangent will show velocity v. Okay, now if we will divide this into two parts, divide means we will resolve, because this velocity is a resultant vector quantity. This velocity is a resultant. So for that purpose here, suppose consider a streamline in xy plane. In that v is a resultant velocity. So in this case, now here we will have x direction along. This is the one component, this is another component, x, and this is x direction component. Okay, this dimension we have taken dx, and this dimension we have taken dy. Okay, this dx along x direction. small dimension dx and velocity u along y directional small element length or dimension dy and velocity small v and angle made by this velocity vector with horizontal theta. Angle made by velocity vector is a theta. So we will express here that u and v are the components, velocity components along x and y direction, along x and y direction. Theta is the angle made by v vector, v made by v with horizontal. Okay, now here to represent, we will represent now in the equation form. In the equation form, if you take this triangle and in that if you take tan theta relation, so tan theta relation will be what? Dy, front side dy, because here is a dy, so its parallel is also dy. So front side dy divided by dx, tan theta is equal to dy by dx. This is what slope of the line. This is slope of the line. Now dy is indicating, or dy is representing velocity v and dx is representing velocity u. So we can have here v upon x, dy upon dx is equal to v upon u. Now this equation we can write in this way also by changing the location of these points, that in this way dx upon u is equal to dy upon v. What we did, this u we bring here u upon dx or dx by u and dy by v in this way. Okay, after that we can multiply, we can take multiplication of this, means what? v dx, okay, is equal to u dy is equal to, and if we bring that in the left side of equality sign, it will come minus u dy. Means here we get this equation. This equation is equation of streamline. So mathematically we get here equation of streamline, that is v dx minus u dy, and this is what? Two dimensional, because here we have considered two velocities. Third axis which is perpendicular to this board, that we have not taken here. So this equation is a two-dimensional equation. So you can write here, this is a two-dimensional equation 2D. Okay. Now this is 2D equation. 3-dimensional equation if you want, then third direction will be added z and third direction velocity w will be added in the equation. So similarly for 3D flow, 3-dimensional flow, we can write this as a what? dx upon u is equal to dy upon v is equal to dz upon w. In this way also you can write this equation. Now there is a special feature or key feature. Key means key, unique feature, key feature of the streamline. That is what? Streamline never intersect each other. Streamlines never intersect, means cross each other. This is a key feature or unique feature of the streamline. Okay, now streamlines are not directly obtained. Actually there is one experiment that is called as flow net. Flow net is a theoretical concept that will come after this session, means next session we will see. By using flow net means there we use electrical method. We pass the current. Okay, we pass the current, we take water, and in the water we allow to flow the current from one side to another side of that equipment. So their voltage is developed between the two sides. Suppose here is a tank, small tank. In the tank water is filled, small height, this much height. Water is filled, and both sides there is a copper plates, and base is also base is not copper, only side plates are copper, metallic. Base may be acrylic. Okay, and then water is filled. Then to these copper plates electrical connection will be given, positive, negative. What will happen? Electron will flow from one side to another side. And then in a physics, in a 12th we have used galvanometer, jockey, pointer. So that pointer we put in the water. So definitely we will find deflection on the voltmeter. So there is one derivation, that derivation will come afterwards. By that derivation, there we say that streamlines are parallel. Okay, flow net we will see that in that concept. Okay, currently we will have this only theoretical representation. Third type is a streak line. Now this line has importance that we will discuss. What is importance? Many applications are there regarding this streak line. Okay, I will show you here two diagrams first of all, and then we will go to the definition, because diagram gives us very clear understanding. Okay, so suppose here we have taken smoke generator. Smoke generator means a small tank, in that smoke is generated. Smoke generator. Okay, smoke generator. Why smoke? Because we need to picturize, means we need to some color. Smoke is a black. Okay, smoke is a black. So that's why we can see that when the smoke comes out of the chimney, boiler. If you see in a sugar industry or any kind of industry where the boiler is, aside the boiler there is a big construction and tall construction, and through that smoke comes. Flue gas, we call it as a flue gas. Carbon dioxide, carbon monoxide. How it looks? It looks black in a nature. So to visualize that we use smoke. So this is a smoke generator, and here the pipe is attached. Okay, this pipe is attached. Here this pipe is given bend in this way. Here the flow control valve to regulate the flow. Okay, and here very small hole like this, nozzle you say. Okay, why? Because to release this smoke. When the smoke will release, it will give this kind of picture to us. Okay, this kind of picture. So this is an instantaneous picture given by this. This is one kind. This is one kind. Another kind or another way. This is in the case of gas line, flow line, gas flow line. This is one kind. If you take liquid, in that case we will have such kind of structure. We will have such kind of structure. We have channel means structure. This is a small cross section and then bigger cross section, and here we have flow of water. Through this we have flow of water. This what we are going to do in the practical also. I will show there in the lab. Okay, this is the flow of water. See, this flow of water is flowing. This water is flowing, but we can't see because water is a colorless. Water is a colorless. How the water is flowing, we don't see. To get visualization, if we add some dye, color, dye or ink, in a simple language, if you just add ink, if we allow to pass ink or dye injected in the flow, what will happen? This dye will follow some path and we will get some this kind of structure. Isn't it? So here we will find here some colored filaments. We call this as a filament. This is called as filament. Filament means line, color line, color filament. Okay. Why we do this? To trace the motion of fluid, to trace the motion of water which is flowing through this. For that purpose we inject the dye. So this is what instantaneous picture. Instantaneous means at the instant when we add dye, we find this. When we stop this dye, it gets vanished. Then colorless water we find. We don't get picture. That is why it is instantaneous picture. So write down here, it is a curve or straight line. It is a curve or straight line which gives an instantaneous means immediate effect. Okay, picture of the location of the fluid particle. Which have passed through a given point. This is what definition of streak line. And here you can have this. We do why? Because to trace the motion, of fluid particles. A colored dye is injected. A colored dye is injected in a flow, injected into the flowing fluid, So resulting picture means this gives line, that is called as streak line. Resulting picture gives, that is called as streak line. Now we will have some example of streak line, practical example or real life examples, okay, of this streak line. So we will have some examples. Very daily life examples you can have. See, this is you understand what I have shown here. It's a simple structure which I have shown here. This is what some kind of industry. that industry is producing some smoke in operation. To release this smoke, okay, at some height, this is what use. It is called as chimney. Okay, so here we find this smoke which comes out. Okay, this what traces of motion. This is called as streak line. Okay, then another example, see, we have in a lab. Which lab? Mechatronics lab. In our mechatronics lab, if you enter, in a mechatronics lab, if you enter, you will find a long one equipment, green color. Okay, that is called as wind tunnel. Wind tunnel. So that wind tunnel is there, and here, suppose we have kept there just for the testing purpose, to find the drag. You know, when the car is moving on the road, okay, from the front side, wind comes, it is striking to the windshield and it develops pressure on it. So to visualize this flow intentionally, this is what points. These are some points. Through these points, smoke is generated. What I am saying, through this point, smoke is generated, and this smoke is intentionally passed forcefully. There is a blower. By using a fan, this smoke is, so when it is flowing, then it is following this kind of path. Say in this way. In YouTube, this is done for the study of vehicle or car to determine the flow distribution, to find flow distribution. Object is kept in apparatus called as wind tunnel. A big tunnel, in that object is kept. Normally Mercedes-Benz, what we see, a high-end car, their shape you will find different than the normal car. Why? Because they have high speed, they have high torque, more power, you say. Ferrari car, Bugatti, there are n number of example you know well. So to study the flow distribution over it, such kind of things are done. So this is example of what? Streak line. So this is what? Smoke flow. And this is first example what we have seen. This is second example, and third example that we do in the laboratory, Reynolds experiment, that we see in the lab today in detail. Reynolds experiment. In that, what is done? In that, there is a pipe, water is passed and ink is injected through that. So it can give you different kind of filament. Suppose this is a straight line, we can say this is a laminar flow. when the filament we get in this way, wavy or zigzag, we call this as a transition. And when we get diffuse flow like this, diffuse, then we call this as a turbulent flow. So here, to recognize type of flow, dye is injected into a flow, which gives us this picture. Okay, and this is what glass tube. Okay, so these are some examples of streak line. So in today's session, types of flow lines, we have seen three types of lines. First is a path line, second is a streamline, third is a streak line. We have taken mathematical treatment for the streamline, we have taken industrial applications and its use for the streak line. Okay.
So at the end of this session, you can explain path line, streamline and streak line. Subscribe the channel Thermal Engineering for further video sessions. Thank you.